Okay guys, we are going over polygons and angles. This is from your Unit 1, Lesson 5. First of all, let's talk about what a polygon is. I know we've gone over this probably 12 million times and you're tired of hearing it. But polygons are closed figures with 3 or more sides. These are not polygons. This is like this little arc thingy, like, you know, rainbow for baby unicorns. Sorry, rainbows and baby unicorns don't count as polygons. This one, however, it looks like a polygon. It's doing this to trick us, but because it crosses, so right here is where it crosses, that makes it a non-polygon. Okay, so now let's talk about interior angles. In order to find the sum of interior angles, we have to take the number of sides and subtract 2 to find the number of triangles. And remember, each triangle is 180 degrees, which is kind of cool. So since each triangle is 180 degrees, we multiply it by 180. So if this case is a 6-sided polygon, also known as a hexagon, and then we subtract 6 minus 2, which would be 4, multiply by 180, and we get a 720. And that is the total number of degrees inside this polygon. Okay? Now, in order to find the individual angle measurement within that polygon, all we have to do, we do the same formula, but then we just divide it by the number of sides, because the number of sides of a polygon is the same number of angles it has. So a 4-sided figure has 4 angles. A 20-sided figure has 20 angles. A 700,000 sided figure has 700,000 angles. Okay, so we're going to do the n minus 2 to find out how many triangles. So this would be 8 times 180. Okay, and that becomes 1,440. And then since this is a 10-sided figure, we're going to divide it by 10, and this gives us that 144 degrees. And that's how much each angle within our decagon is. So that's kind of nice. Okay, so now let's find the measure of each interior angle of a regular polygon with 12 sides. So the first thing I need to do, I'm going to take my 12 and I'm going to subtract 2, because this will tell me how many triangles are inside of it. And this is where we get 10. Now, remember, each triangle is 180 degrees, so I'm going to multiply that 10 by 180. And you guys all get this. It's going to be 1,800. And so this is the total number of degrees within our polygon. But the problem is we need to figure out how much it is for each angle. So now I have to divide this by the number of sides, which is the number of angles, which is 12. And that's 150 degrees. Okay? So now we have this awesome pentagon. Remember, pentagons are 5 sides, and it's given us 4 of the angles. So the first thing we need to do is figure out the total number that the angles should add up to. So if I have 5 minus 2, this is going to give us 3. Multiply it by 180. 3 times 180 is 540 degrees. Okay, now 540 degrees has to be what all of these plus an unknown angle add up to. So let's add those angles together. Oh good, it equals 425 plus this unknown angle measurement. Okay, so I just need to take that 425 and subtract from both sides. So minus 425. So 540 minus 425, and we get 115 degrees equals x, and that is our missing angle. Okay. Ooh, I love these. Okay, so these are vertical angles. We talked about this in lesson 2, I think. So it tells us right here that the measure of angle 3 is 120 degrees. Awesome. Now, angle 4 plus angle 3 is a supplementary angle, so it equals 180 degrees. Okay? Okay, so check that out. And so what happens is this 180 minus 120, I'm sorry, that's going to give us 60 degrees. Okay, so that's one way. The other way is finding that angle 1 is congruent to angle 3, but you have different options. I would try and look for supplementary angles just to make my life a little bit easier. I'm assuming you guys want that too. Ooh, this is another fun one. So A and B are parallel lines, and they have been cut by a transversal C. So angle 3 right here is 130 degrees. And we want to find out what this angle is. Okay, so what we can do is angle 1, because remember this creates a supplementary angle, is going to be 50, because angle 1 plus angle 3 equals 180 degrees. So angle 1 plus 130 equals 180 degrees. Okay, now if we're really careful and we look, really carefully, we can see that angle 1 and angle 8 are alternate outside angles, also known as exterior angles, I'm sorry. So angle 1 and angle 8 are congruent, so therefore angle 8 should be 50 degrees. Let's rewrite that in a color we can all see. So angle 8 equals 50 degrees. That's just one way. You could have also found that angle 3 is congruent to angle 7 because they're corresponding angles, and then gone across. There's a couple different ways we can do this, but this is just the quickest way for us for right now. Okay, now let's talk about this one. I want you to notice that right here, oops, sorry, you can't see that. That's C double prime, okay? So the order that things tend to go in, so you would end up with C is your original, and then your copy is going to be C with one apostrophe for C prime, and then you're going to get C double prime, and then the copy of that would be C triple prime, and then the copy of that would be C quadruple prime. You guys get the idea. It just keeps going, okay? So since this is a double prime, that means that something happened in between this. Now they don't tell us this, but so we took our original triangle, or our blue one. Then we translated it. So remember, translations just mean that we shifted it over, and then we reflected it. So to unreflect it, if you will, I'm going to take the y value and just make it the opposite. So let's start with A. A is at 3, negative 3. So I keep my x the same, but I'm going to make it a positive 3 instead. Positive 3, please. And this is going to be my A prime. Then my B is at 5, negative 6. So I'm going to make it 5, positive 6 for my B prime. And see, I know it looks like you guys are saying, but Ms. Curtin, it's above the x-axis. It doesn't matter, we still have to flip it. So it's 6, positive 2, so it needs to become 6, negative 2. And then I'm going to connect my dots. Ooh, sorry guys. You guys know that I have trouble with this. It's supposed to be just a translation of the blue one. But what we have to write, and remember arrow notation, we are figuring out how many over did we move? How many down did we move to get from one to the other? So we're going to have our x and y, and then we draw our arrow, so remember the arrow notation. Now, we went to the right on our x-axis, which is a positive. So we went from 3 to 5. So that means for all of our x's, I'm adding 2. Now, I went from 12 down to 6, though, on my y's, which means I have to subtract 6 from all of that. But remember, we use arrow notation to show the translations, to show the slides that happen with all of this, okay? If you have questions, let me know. Watch the practices.